to Tennessee's at-home learning series for math. Today's lesson is for all our 8th graders out there, though all children are welcome to tune in. This lesson is the first in our series. My name is Candace Thompson, and I'm an 8th grade math teacher at Oakland Middle School in the Rutherford County School System. I'm so excited to be your teacher for this lesson. Welcome to my virtual classroom. Today, we will be learning about equations and expressions and reviewing writing equations using symbols. Before we get started, to participate fully in our lesson today, you will need the following: paper and a writing utensil or another note-taking device. No calculator is needed today. Okay, let's begin. Today we are reviewing writing equations using symbols. Let's start by thinking back to some things that we've already learned about equations and expressions. Take a look at this mathematical statement and the equivalent expression. The number 1,157 is the sum of the squares of two consecutive odd integers divided by the difference between the two consecutive odd integers. And then here's our equivalent expression. Think about how they are related and which representation you prefer and why. Using letters to represent numbers in mathematical statements was introduced by René Descartes in the 1600s. In that era, people used only words to describe mathematical statements. The use of letters or symbols to represent numbers not only brought clarity to mathematical statements, it also expanded the horizons of mathematics. The reason we want to learn how to write mathematical statement using symbols is to save time and labor. Imagine having to write the sentence, "The number is the sum of the squares of two consecutive odd integers divided by the difference between the two consecutive odd integers." Then imagine having to write the subsequent sentences necessary to solve it. Compare that to the following. Notice that x is just a number. That means the square of x is also a number, along with the square of the next odd integer and the difference between the numbers. This is a symbolic statement about numbers. Writing in symbols is simpler than writing in words, as long as everyone involved is clear about what the symbols mean. This lesson focuses on accurately transcribing written statements into mathematical symbols. When we write mathematical statements using letters, we say we are using symbolic language. All of the mathematical statements in this lesson are equations. Recall that an equation is a statement of equality between two expressions. Developing equations from written statements forms an important basis for problem solving, and is one of the most vital parts of algebra. Throughout this module, there will be work with written statements and symbolic language. We will work first with simple expressions, then with equations that gradually increase in complexity, and finally with systems of equations, or more than one equation at a time. Let's look at 3 examples. While you are watching, follow along on your own paper or other note-taking device. Example 1. Here's the statement we want to express using symbolic language. A whole number has the property that when half the number is added to 15, we get the number itself. First, we define the variable. Let x be the whole number. Using x to represent the whole number, on your own, write half the number. Remember, you can often write expressions in more than one way. Your answer could have looked a few different ways. It could have looked like this: a number divided by 2, or 1/2 a number, or 1/2 times a number. All are appropriate responses. Now, let's write the entire statement. A whole number has the property that when half the number is added to 15, we get the number itself. Try to write the entire statement on your own. Did you write something like this? A whole number has the property that when half the number is added to 15, we get the number itself. Great job. Let's try another example. Let's try this. Here's our next example, example 2. When a number is taken away from 57, what remains is 4 more than 5 times the number. Don't forget to define the variable. Let's let x be the whole number. Start your equation with one part of the statement. How about we start with 4 more than 5 times the number? What would that look like? Write that on your own. Did you write something like this? Are there any other ways that we could write this expression? Correct. We could have written 4 plus 5x. Great. Now let's try this part of the statement. A number taken away from 57. Try to write that part on your own. A number taken away from 57. Did you get something like this? Great job. Remember that in this case, x minus 57 or a number minus 57 or 57 taken away from a number would not be the same thing. All right, let's put the whole statement together. When a number is taken away from 57, what remains is 4 more than 5 times the number. Try to write that statement on your own. Did your answer look something like this? Great. Let's move on to example 3. All right, so we're going to look at this first statement in green. The sum of 3 consecutive integers is 372. The sum of 3 consecutive integers is 372. A couple of things that we want to remember here. Number 1, we've got to define the variable. We'll let x represent our variable in this equation. Next, remember that the term consecutive means one after the next. For example, 18, 19, and 20 are consecutive numbers. So let's try to work through this one together. If we let x represent the first number, or the first integer, what do we need to do to get the next consecutive integer? So if we let x represent the first integer, what do we need to do to get the next consecutive integer? Something I always do when I'm not working with numbers, but I'm working with variables, is I just place in a number. So let's say that 5 is our number. Now remember, we need 3 consecutive numbers, and we know that consecutive means one after the next. So if 5 is the number I start with, what would be my next number? 6. So let's think about this. What did I do to 5 to get to 6? I added 1. So let's use that same logic here. If I start with x, what would I do to get the next consecutive number? I would add 1. So my next consecutive number would be x plus 1. Okay, now this is only 2 consecutive numbers. How many does the problem say I need? It says I need 3 consecutive numbers. So let's still use this example here. What would my next consecutive number be? 7. Now, starting with that original number 5, what did I do to get to 7? I added 2. So applying that same logic here, if I start with x, I'm going to add 2 to x to get my third consecutive number. Now, express the statement, the sum of 3 consecutive numbers is 372. The sum of 3 consecutive numbers is 372. I apologize for whatever reason. Nope, I got lost. I was looking here. The sum of 3 consecutive numbers, or 3 consecutive integers, is 372. See if you can put all of that together into a mathematical statement. Did you get something like this? X plus x plus 1 plus x plus 2, and the sum of all of that should equal 372. Now, you may also choose to rewrite this equation by combining like terms. So we know that x plus x plus x, that would give me 3x plus 1 plus 2 would give me plus 3 equals 372. Transforming equations such as this one to a more simplified equation is going to be our focus for the next few lessons when we begin to solve linear equations. For right now, we're just simply trying to take this sentence and create a mathematical statement. We're not really focused on solving or combining like terms, but it's always good to know how to do that. Okay. Now let's move on to some guided practice. So this will work kind of the same way. I'm going to give you an opportunity to write this on your own. Again, if at any point you are trying to work and I'm going too fast, please feel free to stop your video. All right, here's practice 1. The sum of 4 consecutive even integers is equal to 28. The sum of 4 consecutive even integers is equal to 28. Now notice the difference between this problem and the previous problem. The previous problem just said 3 consecutive integers, whereas this problem says 4 consecutive even integers. Think about how that would change your mathematical statement. Try to write this one on your own. Again, if at any point I'm going too fast, please feel free to stop your video. So let's see if you got something like this. Let's let x be the first even integer. And again, we're going to use that same logic where we're just going to start with an even number and see if we can use that same logic and philosophy to figure out how to build our mathematical statement. So let's say I start with an even number 12. Okay? Now, what would be the next even number if I started with 12? 14. 14 would be my next even number. What did I do to 12 to get to 14? I added 2. So I'm going to apply that logic here. If I start with x to get my next even number, I would just add 2. Okay, now we need our third even number. So again, going back to this example, if I start with 12, I go to 14, what would be my next even number? Great, 16. What did I do to 12 to get to 16? I added 4. Great job. So my third consecutive even number would be x plus 4. Now let's go back and read the problem, because at this point we've been working and it might be best for us to revisit the problem. It says the sum of 4 consecutive even numbers. Well, I have 3, I need 1 more. So let's go back to our own little example that we're trying to use to build our statement. What would be my next even number? What would be the 4th even number here? 18, great job. What did I do to 12 to get to 18? I added 6. Now, let's go back and read the problem one more time. The sum of 4 consecutive even numbers is equal to 28. So what that tells me is when I add x plus 2 plus x plus 4 plus x plus 6, the sum of all of that should equal 28. Now, just like in our previous example, we can combine like terms to make this a more simplified equation. Again, that won't be our focus until later on, but it's always a good thing to practice. So I'm going to combine every term that has an x. So I have 4x, and then I'm going to add 2 plus 4 to get 6, and then 6 plus 6 to get 12. And I'm going to set that equal to 28. All right, exercise 2. Again, I'll give you some time to try to work this one out on your own, and then we will discuss as a class. Stephen has some money. If he spends $9, then he will have 3/5 of the amount he started with. I would like you to try on your own to create your mathematical statement. Remember, if at any point I'm going at a faster pace than you would like, please feel free to stop your video. Let's see how your answer compares to mine. Did you get something like this? Stephen has some money, so we'll define a variable. We'll let x define some money. And he spends $9. So that amount of money he has, it's going to decrease by $9. And he has 3/5 of the money he started with, and he started with x. Did your equation look something like this? Remember, at any point you could put parentheses around that. Great job. Now we will review some key points from our lesson today. We know how to write mathematical statements using symbolic language. Written mathematical statements can be represented as more than one correct symbolic statement. We must always begin writing a symbolic statement by defining our symbols or our variables. Complicated statements should be broken into smaller parts, or try working them with simpler numbers. Now let's try some extra practice. We'll call this your exit ticket. So we'll start with number 1. When you square 5 times a number, you get 3 more than the number. Let's start with that one first. Try this on your own. When you square 5 times a number, you get 3 more than the number. Take time, create your mathematical statement. Okay, let's move on to number 2. Monica had some cookies. She gave 7 to her sister. Then she divided the remainder into 2 halves. She still had 5 cookies left. Take some time, create your mathematical statement. Let's compare answers. Remember, if at any point I'm going at a faster pace than you would like, please feel free to stop your video. Okay, our first one. When you square 5 times a number, you get 3 more than the number. So when you square, or when you raise to a second power 5 times a number, so 5x raised to the second power, you get 3 more than the number. So your statement should look like this. 5x squared is equal to x plus 3. Our second statement. Monica had some cookies. She gave 7 to her sister. Then she divided the remainder into 2 halves, and she still had 5 cookies left. So Monica had some cookies. We don't know how many cookies she had. We'll let X represent the amount of cookies she had. She gave 7 to her sister. So 7, her amount of cookies decreased by 7. And then that remaining amount of cookies she had, she divided it by 2, or she broke it into 2 halves. And she still had 5 cookies left. Remember, if at any point I'm going faster than you would like, please feel free to pause your video. Okay, so for extra practice, if you would like to, you can get on the Tennessee Department of Education website where there will be 5 additional problems. Because we still have a little bit of time, we're going to do some together. You can think of this as homework after the lesson. So we are going to start with example number 3. If you don't have that worksheet pulled up, it's not a big deal. I will write it on the board and we'll work it out kind of in the same manner we've been doing the rest of the problems. So this is number 3 on your grade 8 lesson 1 worksheet. And it says the sum of 3 consecutive numbers excuse me, 3 consecutive integers. I want to use the exact same vocabulary. The sum of 3 consecutive integers is 1,623. Take some time and see if you can come up with your own mathematical statement. For sake of time, we'll go over this together, but remember, if at any point I'm going at a faster pace than you would like, please feel free to pause your video. So let's break down this statement we have here. The sum. So the sum is what? The sum is the answer to an addition problem. So I know I'm going to be adding something here. What am I adding? I'm adding 3 consecutive integers. Do we know what those integers are? No, so we're going to let X represent that first number. Now remember, if this works for you, then use this technique. If I start with 3 and I want to come up with, let's start with something that's not the same as that. Let's start with 4. And I want to start with 3 consecutive numbers. Remember, I gave you examples of that before. 18, 19, and 20 are consecutive numbers, just one right after the other. So if 4 was the number I start with, what number would come next? What would be the next consecutive number? 5. What did you do to 4 to get to 5? We added 1. So the next consecutive number would be 1. If we went by this logic, my next number would be 6. What did we do to our original number to get to 6? We added 2. Now, the problem says I need 3 consecutive numbers. Do I have 3 consecutive numbers? Great. Now, what does it say about those 3 consecutive numbers? It says that the sum of them is equal to 1,623. So, I'm going to add x plus 1 plus x plus 2. And when I add all of them together, I should get 1,623. Now remember, this will be the focus of our next lessons, but it's always great to practice this. Let's go ahead and make this a simpler equation. Let's simplify it by combining like terms. X plus x plus x would give me 3x. And then 1 plus 2 would give me 3. And that's equal to 1,623. So we have done one of the 5 practice problems that we have provided for you. I enjoyed doing some mathematics with you today. Thank you for inviting me into your home. I look forward to seeing you in our next lesson, Tennessee's At Home Learning Series. Bye.